Good morning. Myself, Dr. Hemawati, Patil, Assistant Professor of Mathematics, Government First Grade College, Manhalli. Welcome to video lecturing on B SC II SEM Mathematics. In previous videos, we have solved problems on Euler's theorem, that is on homogeneous functions. Let us take some more examples on the same topic. If u is equals to x raised to 5, y raised to 5, sin inverse of y by x, then show that x ux plus y uy is equals to 10u and x square uxx plus 2xy uxy plus y square uyy is equals to 9x ux plus y uy. Let us take here u as it is. U is equals to x square plus x square into y square sin inverse of y by x. Let us try to express this one in the homogeneous form. So here we have y raised to 5. Definitely we need divided by x raised to 5. So therefore we have to take x raised to 10 common, so that we will get y raised to 5 divided by x raised to 5. Even though here we have x raised to 5, so we have to take x raised to 10 common because we want here x raised to 5. So for that, multiplying and dividing by x raised to 5, you will get x raised to 10 into y raised to 5 divided by x raised to 5 into this sin inverse of y by x as it is, because it is into. No need to divide this second sin inverse y by x also with x raised to 5. So u is equals to x raised to 10 y of y by x raised to 5 sin inverse of y by x. It is in the form of x raised to n phi of y by x, which is the homogeneous form. So therefore this implies here u is a homogeneous function of degree. Here this power n, compare these two, you will get here n is equals to 10. So u is a homogeneous function of degree 10. That is here we know homogeneous functions satisfies Euler's theorem. Therefore by Euler's theorem we have x into dou u by dou x plus y into dou u by dou y is equals to n into u. So this implies x into dou u by dou x plus y into dou u by dou y is equals to, substitute the value of n. Here we have n is equals to 10. It is equals to 10u. Take this one as equation number 1. So this is the first one. First part we have done here. Show that x ux plus y uy is equals to 10u. We know ux is dou u by dou x and uy is dou u by dou y. So first part is over. Let us prove the second one. To prove the second one, we have to do like this here. We have to differentiate equation 1 partially with respect to x. Then we have, here it is x into dou u by dou x. Both are functions of x, because here dou u by dou x contains x and y both. So it is product of two functions. You have to take this one as here first function and this one as second function. So it is product of two functions. First function as it is derivative of dou u by dou x with respect to x means dou to u by dou x square, plus this second function dou u by dou x as it is derivative of x partially with respect to x means 1. So we will write this one as here into 1. So plus this second one y, because here we are differentiating partially with respect to x, you have to treat y as constant and this y as it is, and dou u by dou y, we know dou u by dou y contains x also, therefore we can differentiate this. It is not a constant, don't get confused. So here it is differentiating this one partially with respect to x means dou to u by dou x dou y. This is equals to 10 into dou u by dou x. Because we want to prove x squared uxx means x squared dou to u by dou x square. So for that, multiplying this on both sides with x, you will get x squared dou to u by dou x square plus x into dou u by dou x plus x into y dou to u by dou x dou y is equals to this 10x into dou u by dou x. Take this one as equation number 2. Similarly, let us differentiating equation 1 partially with respect to y. Let us differentiate this partially with respect to y. So while differentiating here, x, we have to treat x as constant. So x as it is into derivative of dou u by dou x partially with respect to y means here x into dou to u by dou y dou x, plus here again it is product of two functions while differentiating partially with respect to, in second case it is not in first case. This is first function, this one is second function. In second case it is. So y as it is, first function derivative of dou u by dou y is dou 2u by dou y square, plus second function this dou u by dou y as it is, derivative of y partially with respect to y is 1. So it is into 1. So this implies here, this is equals to, again RHS is 10 into u. You have to differentiating with partial with respect to y means 10 into it is dou u by dou y. Now multiplying this on both sides with again y here, because we want to prove this one as dou u by, this second one is y, this is y square into dou u by dou y we want here. So it is multiplying this with y, we will get here xy dou 2u by dou x dou y plus y square dou 2u by dou y square plus y into dou u by dou y is equals to 10y into dou u by dou y. Take this one as equation number 3. Now adding these two equations, adding equations 2 and 3. So adding equations 2 and 3, what we have here, in equation 2 you have to add LHS. So LHS is x square dou 2u by dou x square, and here in this you write as it is, this you write as it is here, x square dou 2u by dou x square, then plus here we have in equation 3 this one xy dou 2u by dou x dou y. In equation 2 also we have xy dou 2u by dou y square, you will get this one, and similarly plus y square dou 2u by dou y square and plus x dou u by dou x plus y dou u by dou y is equals to, adding RHS you will get 10x dou u by dou x plus 10y dou u by dou y. So this implies here x square dou 2u by dou x square plus 2xy dou 2u by dou xy plus y square dou 2u by dou y square is equals to 10 x dou u by dou x plus y dou u by dou y, and take here this x dou u by dou x plus y dou u by dou y in RHS, it becomes minus. So this LHS as it is 10 minus 1 x dou u by dou x plus y dou u by dou y is 9 times of x dou u by dou x plus y dou u by dou y. So this is the solution. Similarly, let us take one more example. If u is equals to x cube y square sin inverse y by x into cos inverse y by x, then prove that x ux plus y uy is equals to 5u, and second one is same, x square uxx plus 2xy uxy plus y square uy is equals to 20u. Let us take here u as it is, and in this let us take here we have y square. Definitely we need x square in the denominator, so multiplying and dividing by x square, you will get here x raised to 5 into y square by x square, and remaining term as it is sin inverse y by x into cos inverse y by x. So it is again in the form of x raised to n phi of y by x. So this implies here u is a homogeneous function of degree, here n is equals to 5. So therefore by Euler's theorem we have here x into dou u by dou x plus y into dou u by dou y is equals to n into u. This implies this is substitute the value of n, x dou u by dou x plus y dou u by dou y is equals to 5u. Take this one as equation number 1. Let us differentiating equation 1 partial with respect to x. Again here we will get, so this is product of two functions, because here x into dou u by dou x. So x into dou 2u by dou x square plus second function as it is dou u by dou x, derivative of x is 1 plus y constant, treat y constant, and derivative of dou u by dou y is dou 2u by dou x dou y is equals to this 5 into dou u by dou x. Similarly, let us differentiating equation 1. First you have to multiply this with x. Then you will get here, you will get x into dou 2u by dou x square plus x dou u by dou x plus x dou 2u by dou x dou y is equals to 5x into dou u by dou x. Take this one as equation number 2. And let us differentiating equation 1 partially with respect to y. So you know again equation 1 is what? Equation 1 is, we know this is equation 1. Equation 1 is x into dou u by dou x plus y into dou u by dou y is equals to 5u. So let us differentiating this partially with respect to y. This x into x is, you have to treat constant, derivative of dou u by dou x with partially with respect to y is dou 2u by dou x dou y. Then plus, here again it is product of two functions, both are functions of y. So this one, first this y as it is, and derivative of dou u by dou y is dou to u by dou y square. This is dou to u by dou y square. Then plus the second function dou u by dou y as it is, derivative of y with respect to y is 1 into it is 1 is equals to 5 into this is dou u by dou y. Multiplying on both sides with y, we have here xy and this dou to u by dou x dou y as it is, plus y square dou to u by dou y square as it is. This one is not xy, it is y square. Then plus y into dou u by dou y is equals to 5y dou u by dou y. Take this one as equation number 3. Now adding these two equations, adding 2 and 3. Let us add these two equations, 2 and 3. Let us take this first term, x square dou to u by dou x square. Here we don't have any such term, so you write this one as it is. X square dou to u by dou x square plus. Here we have in equation 2. In equation 2 we have here x into no. So it is x into y. This is x into y. We have to multiply on both sides with y. So adding these two equations. This is adding these two equations, we have here 2xy dou to u by, this is xy dou to u by dou x dou y. Here also we have here xy dou to u by dou x dou y. It is 2 times of xy dou to u by dou x dou y, plus this one. In third equation we have y square dou to u by dou y square. Then plus in second equation we have x dou u by dou x, and in third equation we have y dou u by dou y is equals to add RHS also, 5 into x dou u by dou x plus 5 into y dou u by dou y. And this keep this LHS as it is, and here in this, in place of this x dou u by dou x plus y dou u by dou y, you will take here it is from equation number 1. From equation number 1 we know this is our equation number 1. This is equals to 5u. Add that. This is 5u is equals to, take 5 common in this, and remaining term is x dou u by dou x plus y dou u by dou y. So this is 5 into, and this bracket is again from equation number 1, it is 5u. So it is 5 into 5, 25u. Take this 5u in RHS, it becomes minus 5u. So this implies here x square dou to u by dou x square plus 2xy dou to u by dou x dou y plus y square dou to u by dou y square is equals to 20u. So this is the second result. This completes the solution.